Hello, this is Shushmita and welcome to the session 1 of Kinematics. Kinematics is nothing but the study of objects in motion. The approach that we are going to take for this chapter is we are going to learn the theory through solving problems. So let's get started with our first problem. Here they have given that a man moves in an open field such that after moving 10 meters in a straight line, he makes a sharp turn of 60 degrees to his left. The total displacement of the man just after 7 such turns. So to solve this problem, you need to have a concept of distance and displacement. Let me show you with a very simple example. Suppose this is my home and this is the grocery store near my home, and the path to the store is like that. So I move from here, let me call this as point A, through point B to point C. And if this is 50 meter, this is 50 meter, then the total distance I have traveled to reach the grocery store for my home is simply 50 plus 50, which is 100 meter. This much you can figure out. But if somebody asks you what is my displacement, then it will be the shortest distance between A and C, which is a straight line. So this is my displacement. Displacement, apart from having a value, also have a direction. So my displacement is in the direction of C from A. So this is denoted as a displacement, and this will have a value of AC, which is 50 square plus 50 square root over, or 50 root 2 meter. So now you see that the distance traveled and the displacement are two different things. Similarly, after I have done buying all the things, I have returned home by the same path. So at this moment, the distance I have traveled has increased and it has become 100 multiplied by 2. So 200, because I had to go from here to here and then again come back from here to here. So I had to travel double the path. So now it has become 200 meter, which is the distance traveled. But what is my displacement? My initial and the final position is same. I am at home now. So my displacement becomes 0. In this question, if you read, they are saying a person is moving in a straight line like this, which is up to 10 meter. So he has started from here. Let us call this point A. He is now at point B. And from this point, this will be his right and this will be his left. From his left, he is turning towards the left to 60 degree. So this is a 90 degree angle. This will be approximately 45 degree. 60 degree will be somewhere around here. So this angle is 60 degree. So he is standing here, but he is turning like this. And he is making 7 such turns. So another 60 degree, another 60 degree, and moving on, so on. But he is standing at the same point B. So no matter in which direction he moves, he is still standing at the point B. So his displacement is only the distance between A and B, which is 10 meter. So 10 meter is our answer. Moving on further, this is a question that involves speed, and while solving this problem, we will build up our concept of speed and velocity. It is same like distance and displacement. So speed is how much distance a particle travels, and to cover the distance how much time it takes. If we write it in the equation form, it will be like this, or x, distance traveled, we can find out by multiplying speed with the time that was needed to travel or cover up that distance. But velocity, on the other hand, is a vector quantity which have a value as well as a dimension. So if the particle is moving in this direction in a straight line, consider, and let us call this distance as 10 meter, and the particle has taken say 5 seconds to cover the distance. So I can write the speed is equal to 10 by 5 meter per second or 2 meter per second. But the velocity will be, let us call this direction. So it will have a value of 2 meter per second along with the direction. So let me call, there is a unit vector along this direction which has a value of 1. So it does not add up anything to our measurement, but it only provides the direction. So we can write the velocity as 2 meter per second I cap. Now if a particle is moving in a circular path, then the speed of the particle remains same at any point on the circle. It is moving like this, suppose, but the velocity, direction of the velocity keeps on changing. So if we take the average of the velocity over one complete circular rotation, it comes out to be 0, or it is a null vector. A zero vector, a vector that has a 0 value, is called a null vector. Null means it has nothing, no value, or the value is 0. So let us now look into our problem. Particle is moving in a straight line and it covers half the distance with a speed of 3 meter per second. So let me consider, this is the straight line. Particle is going from point A to point E, and half the distance, let us say that AB is equal to BE. Let me take this entire distance as 2x. So AB and BE becomes x, which is half. So it travels this path from A to B with a speed of 3 meter per second. So what information we have about the section from A to B? The speed, let me call this B1, is 3 meter per second. Let me call the time taken to traverse the distance as T1, and the distance is equal to x. So what relation can we establish between them? X is equal to V1 T1, or x is equal to 3 into T1. That is the relation we have. For the next half segment, he covers it in 2 equal time interval. So suppose in the first time interval he goes up to a point C. He travels that interval with a speed of 4.5 meter per second, and the rest half time interval he covers in 7.5 meter per second. So now the distance from B to E is x meters, isn't it, from here? And the time taken to cover BE becomes, let me call this 2t2. So the time taken to go from B to C is t2, and from C to E is t2, as per our question, 2 equal time interval. But he travels with a speed of 4.5 meter per second. So in the first half of the time, he travels a distance which is the velocity multiplied by time. In the second half interval, he travels with a speed of 7.5 meter multiplied by t2. So this is the distance traveled, and this distance is the same as that of BE, or equal to x. So x becomes equal to 12 t2. So now we have two relations connecting x, t1 and t2. They are asking us for the average speed of the particle during the motion. So average speed is nothing but the total distance traveled divided by the total time needed to cover that distance. The total distance traveled is 2x from A to E, and the total time needed is t1 plus 2t2. So what we can do is, we can simply write here 3t1, because x is equal to 3t1, which is equal to 12t2. This becomes 4, or t1 is equal to 4t2. So it remains 2 into, in place of x we can write 12t2, and t1 is 4t2 plus 2t2. So this becomes 6, this becomes 2 into 12, so it becomes 4. So the average velocity is 4 meter per second. So while solving this problem, we learned about another two quantities, that are velocity and speed. This is a problem where they have given us the coordinate of two particles. So coordinate are nothing but It is a reference to indicate the position of a particle at any particular time. There are different types of coordinates that you can use, but one of the easiest or one of the most used coordinate is the rectangular coordinate, or also called the Cartesian coordinate. If you look at one corner of your room, you will see that the two walls meet up like this. So along your floor you get two lines that are moving at 90-degree angles to each other, and then you get one common line joining the two walls up to the ceiling. You can consider this axis as the z axis and the two lines along your floors as the x and the y axis. So this is the rectangular coordinate in 3 dimensions. In this 0, 0, 0 means the origin of the coordinate system. So our particle A, which has a coordinate of 0, 0, 0, is at the point origin of the coordinate system. And our particle B has a dimension minus 30. That means we have to move 30 divisions in the x-axis towards the left. So somewhere near here, because its x, y and z coordinates are 0. So our particle B is somewhere on the x-axis, 30 divisions along the left. Now the velocity of the particle A is given. Velocity, which is a vector quantity, is represented as, I told you that I cap, j cap are the unit vector along the x-axis, along the j-axis, along the k-axis. So they have a value of unity or 1. They represent the direction along which the velocity components are represented. And the particle B has a velocity of 10 I cap plus 5 j cap plus 5 k cap. Now if the velocity of them remains same, or even if the velocity keeps on increasing, the only criteria that should meet for the particles to collide with each other is that their relative velocity must be decreasing. So let us find out the relative velocity of A with respect to the velocity of B, which is defined as VAB, that is written as the velocity of A minus the velocity of B. And when we are subtracting two vectors, we will subtract the components of the each vector separately. So for the I cap coordinate along the x-axis, we will subtract the two components. Then we will do the same for the components along the y-axis and the component along the z-axis. So this becomes 0 obviously. So we are left with minus 5 I cap. So our relative velocity is minus 5 I cap. So if this is my particle A and this is my particle B, and if they are moving like this, then there is a possibility of colliding only if the distance between them is decreasing. So let us now find out the relative distance of B with respect to A. The relative distance of B with respect to A must be decreasing for them to collide, right? So in the similar manner, the relative distance of B with respect to A is the relative position of B minus the position of A. The position of B is minus 30 along the x-axis, so minus 30 I cap, minus this is at 0 and yz components are 0, so we are disregarding that, so it becomes minus 30 I cap. So this is also reducing and the relative velocity is also reducing. So yes, they are going to collide. Now they want to know after how much time are they going to collide. So we know that velocity is equal to time travel divided by distance. So time is x by distance by velocity. So here the value of our distance is 30, which is also called the modulus, and the modulus of velocity is 5. So it becomes 6 seconds. So they are going to collide after 6 seconds. Moving on to our next problem, we will learn how to find out the average of any quantity. The average of a quantity is defined using the integration as Suppose we are to find out the average of x over a time period from 0 to t. Then we can define the average as from 0 to t x dt divided by. Now the analogy, I'll try to draw the analogy. Suppose we are given two values x1, x2, x3 and we want to take an average of the value. What are we going to do? Usually what we do is we take a sum of the quantities and then divide it by the number of times we have taken the measurement. So we are going to write it like this. So here they have given us, they want to find out the average of the velocity. Velocity is given by 2t plus 3. So what will be the average of velocity? We have to take the sum over the time interval from 0 to 1 and we are also dividing it with the total time. So it becomes from 0 to 1 2t plus 3 dt. In the mathematics we learn about integrations and derivatives, so do not worry. 2 is a constant, it will come out. T is t square by 2. We have to take the limit from 0 to 1 plus 3 into dt is integral to t, and this dt will become t after integration and we have to put the limit from 0 to 1. So 2 into half plus 3 divided by 1. So it becomes 4 by 1 or 4. So the average velocity is 4 meter per second. So while solving this problem, we also learned how to take average or time average of a quantity. We are now going to move on to our next problem, and this is a very interesting problem. There are 4 points on a vertical line. It starts from A, goes to D, such that AB equal to BC equal to CD. So this line is divided into 3 equal parts. Let me call this B and this C. So they have given that AB equal to BC equal to CD, and a body falls from rest at A up to D. They want to know the time taken in traveling from A to B, from B to C, and the time taken in traveling from C to D. So at this point the initial velocity is 0. While solving this problem, we have to learn about 3 equations. One of them we already know, and that is simply velocity at any point is equal to the distance traveled at any point is equal to velocity multiplied by time. Now if the particle has some acceleration, then the velocity will keep on changing with time. So let me consider this is a velocity versus time graph of the particle, and at this instant it has a velocity of u. Now the time is t1. After some time we have pushed the particle, and after some time, say at t2, the particle gains a velocity of v2. So this is my time t1 and t2. This is u and this is v. So the slope of this graph is the change along the y-axis, which is v minus u, by the change along the x-axis, which is t2 minus t1. So this is our time interval. Let us say the interval is t, v minus u. This is the rate of change of velocity, and the rate of change of velocity is nothing but acceleration. So this becomes at is equal to v minus u, or v is equal to u plus at. That is true when the particle is accelerating. If the particle is decelerating, we will have to put a minus sign, because after some time the particle will come to a rest, or the final velocity will become 0. That means when u equals at, then the particle will come to the rest. So this is one of the equations that we have to remember. Another equation that we have to remember is the time taken in traversing a distance or a height of h. when the initial velocity is not equal to 0. So we know that the distance traveled is the velocity multiplied by the time taken. But this velocity is now not the instantaneous velocity. The initial velocity was u and the final velocity at this point, let us say, is v. So this velocity will change and it will become the average velocity, which is u at the beginning, at the end, divided by 2. Now we can replace v using our formula. If the initial velocity was u and the particle is accelerating at a rate of at, then this becomes u plus at by 2 into t, or 2u plus at by 2 into t, or this becomes u plus half at into t. That comes out to be ut plus half at square. So s or h is equal to ut plus half at square. This is another formula that we are going to remember for solving the problems in kinematics with these. Now here they are asking how much time will it take to travel from A to B. We can use our formula. Let us consider it is falling under the reaction of gravity. So we are replacing the acceleration with acceleration due to gravity. Now at this point A, the initial velocity was 0, so this ut term cancels out and h becomes half gt square, or the time taken to travel is root over 2h by g. If you remember, we deduced this equation in the dimensional analysis class. So let me consider all these sectors are equal to h. So the total height is, let us consider 3h, and each of the sector equals to a distance of h. So this is our TAB. Let me write it down. We are now going to use the same equation to find out the time taken in going from A to C. So the time taken in going from A to C, the initial velocity is again 0, so this term cancels out, and so now it is 2h. From A to C, the distance is 2h into half g t A to C whole square. So t, time taken in going from A to C, now becomes 4h by g root over. So how can we deduce the time taken in going from B to C? It is simply the time taken in going from A to C minus the time taken in going from A to B. Is it not so? So this becomes 4h by g minus root over 2h by g. Now we are going to find out the time taken in going from C to D. For that, we are going to find out the time taken in going from A to D and then subtract the time taken in going from A to C, so that we will get the time. If we subtract this from this, then we will get the time taken in traversing C to D. So we will have to find this out. You see, from A to D, the distance is 3h. So half g t from A to D square. So t A to D becomes root over 6h by g. So we get t C to D by subtracting t A to C from this. So this becomes root over 6h by g minus this, root over 4h by g. So root over 6h by g minus root over 4h by g. Let us take root over 2h by g common. So this becomes root over 2h by g is 2. Root over 2h by g, this is root 2 minus 1 is 2. Root over 2h by g root 3 minus root 2. Or this is the final ratio. There are many interesting problems that we are going to solve throughout this chapter, and we are going to build up our problems, build up our concept by solving problems. Let us now look into this. There are two trucks that are moving towards each other, and the distance between them is decreasing at a rate of 10 meter per second. They are telling us that the distance is decreasing, but you see that they have given us in the unit of meter per second, which is the velocity. So it is nothing. They are saying the distance is decreasing at the rate. That means they are giving us distance by time, which is the expression for velocity. And these trucks travel in the same direction. Separation increases at a rate. So if they are traveling in the same direction, then their resultant velocity or the resultant speed is becoming 5 meter per second. If they are moving in the opposite direction, it is becoming 10 meter per second. Now you have seen this, you have experienced this phenomena in your everyday life while you are moving through a train and another train crosses you from the opposite direction. It appears to you the train is moving very fast, but indeed the train is traveling at a slower speed. So when two objects are moving towards each other, their relative velocity adds up and it appears that they are moving faster than they are actually moving. So in this case where they are moving towards each other, for the moment let me say that one of the truck has a velocity v1 and the other truck have a velocity of v2. So these two velocities will add up and it will become more than their original velocity. On the other hand, when one particle is traveling, both the particles are traveling in the same direction, then their speed is subtracted. So the who is moving at a speed, let us say 80 kmph, and you are traveling at a speed of 70 kmph, apparently he will not seem that much faster to you. So when they are traveling in the same direction, their velocity is subtracted from each other. So this becomes 5. Now we are left with two equations. We will have to solve for v1 and v2. Simply we are going to add these two equations up. So we are going to get 2v1 is 15, or v1 is equal to 7.5 meter per second. So v2 is going to be v1 minus 5 using this equation, that is 7.5 minus 5, which becomes 1.5. Sorry, this is going to be 2.5 meter per second. So these are the two velocities. If we found out v2 using this equation, you see we could also do that 10 minus v1 or 10 minus 7.5, that will also give me 2.5 meter per second. So one of them have a velocity of 7.5 meter per second and the another one have a velocity of 2.5 meter per second. Before we move on to our next problem, I am going to give you a very brief idea about vector addition and the projection of vector, or how to find out the component of a vector along a particular direction. There are two laws of vector addition. One is the triangular law, which says that if suppose this is a vector A and this is a vector B along this direction, then the resultant of the two vector, or if you want to add up the vector A plus B, that is what we call the resultant. The resultant of the two vectors will be along this direction. So this will be A plus B, and this is the triangular law of addition of vector. There is another law in which, suppose this is my vector A along this direction and this is my vector B along this direction. Now when we represent a vector with a line, that means from here to here the modulus or the value of the line is A. If it is in distance, then the value is say A meter, and this direction indicates that the vector is along the direction, let us, if this is our x-axis, then positive x-axis. So to find out in the rectangular or the parallelogram rule, to find out the resultant of these two vectors, we will complete this parallelogram and the resultant will be along the diagonal. So this will be my A plus B. So these are the two laws of vector addition. Now we know that this is a vector, we can write this vector as the value of it. This is called the modulus of the vector, that indicates the value that the vector has into or multiplied by its direction. So if this is our x and y coordinate, and let us for the moment consider that the vector is along the x axis, which is represented by unit vector I cap. So this means we can write our vectors like this, and if this is say along the y direction, so B is along this direction, A is along this direction, we want to find out the resultant. So we know that the resultant will be along this direction, or the resultant vector A plus B will, if we want to find out the modulus of A plus B, then the modulus would be nothing but the square of the component multiplied by 2 into the vector A dot product of the two vector. Now dot product of the two vector is nothing but the projection of the vector A on along the direction of the vector B. That means if the angle between them is theta, we A dot B means the projection of A along the direction of B, or we can express that in terms of a cosine function. So this means 2 into mod A mod B multiplied by cos theta, if theta is the angle between the two vectors. Now suppose a vector, resultant vector is given, and we want to find out the component of this resultant vector along the x-axis. I told you that it is the projection. So if this angle is theta, the component along the x-axis would simply be r cos theta. Similarly, the component along the y-axis will be r sin theta. So this distance will be r sin theta. And you must remember this concept throughout this course, because this will come very handy. Depending on this, we are going to solve our next problem. So let us move on to our next problem. While solving this problem, you are also going to learn about a new concept, and that is the frame of reference. To give you an easy example, suppose you are in a moving train and you are sitting on the train. So you think that you are at rest because you are sitting on a seat inside the train. So if we take the train as a frame of reference, you are at rest on that frame of reference. But to someone who is standing outside the train, suppose he is waiting for the train at station, to him you are moving along with the train, so you are not at rest even though you are sitting inside the train. So that is the frame of the observer, and from where you are observing your state at rest is the reference frame of the train. So that is what reference frame means. It is the frame from which you are making the observation. So let us now look at our problem. Here it is given a ball is thrown vertically upward with a velocity u from the balloon descending with a velocity v. That means this is a hot air balloon. There is a person inside the balloon and the balloon is descending. So at this point, this person throws a ball upward. So the ball will go, but gravity is pulling the ball downward. So he throws the ball upward with a velocity u, and the ball is accelerating towards upward because he has given it some force. But due to the pull of gravity, the velocity will slowly decrease, and after a point the ball will stop for a second and then start falling downward. So let me consider the ball stops here and then start falling downward. Now the ball is falling, also the balloon is descending. So the balloon has now come up to this place. Let us consider this is our ground. So the ball is falling like this. So after some time the ball will cross the balloon again and then fall towards the ground until it hits the ground. So they want to know at which time the ball will cross the balloon once again. Now if you have, I think we have already solved the problem. Here we are going to solve the problem from the reference frame of the balloon. So I had told you in the dimensional analysis we solve the problem. Suppose a ball is falling from this side and okay, for the moment let me consider we have thrown a ball upward from this. This is a ground. So from here I have thrown a ball upward with the velocity of u. So it has a vertical velocity of u. It will go up to a height h, and that height can be written as ut minus half gt square. Here initial velocity is not 0, and the velocity at this point will be 0 because it will go like this, stop for a moment and then start falling downward. So at this point at height h, the velocity is 0, or the velocity can be written like this. So 0 is u minus gt, or time is equal to u by g. So if the ball is thrown upward with the velocity, initial velocity of u, then the ball will reach the height h after a time t, and it will take the same time to fall downwards because the only force that is acting on the ball now is the force of gravitation. So it is pulling it down with the same acceleration now. So now if we consider the motion of the ball from here to here, then at this point again the velocity becomes 0. When the ball hits the ground, then the velocity, it hits the ground with the maximum velocity because the gravity is pulling the ball downward and the velocity of the ball is accelerating. So now the initial velocity, now consider this final velocity is v prime, and this will be the initial velocity which is v, that is equal to 0 plus gt, or the final velocity becomes g into t, and t becomes v prime by g. Now both of these velocities are equal, and we can write that the time taken by the ball to reach the height h is the same as the time taken by the ball to fall down from a height h. So the total time of flight means the total time at which the ball is in the air. So it starts right from here when we throw the ball upward till the ball hits the ground. This time can be written as 2t, or 2u by g. This is called the time of flight. We are going to use the same equation to solve our problem, except for that we are going to use the frame of the balloon as the frame of reference. Because our observer is in the balloon, so we are going to use the balloon's frame as the reference frame. So from the reference frame of the balloon is descending downward with the velocity v, and the ball is thrown upward with the velocity u. So they are moving in the opposite direction, so the relative velocity will add up, divided by the gravitational acceleration, and the total time of flight is multiplied by 2. So this will be our option. Hope it is clear to you. It was a very interesting problem. Our next problem is also going to be interesting. So let us look into this problem. Here they have given that a swimmer swims in still water at a speed of 5 km per hour. So let the speed of the swimmer be 5 km per hour, and if we convert 1 km per hour into meter per second for our convenience, then it becomes 1000 meter divided by 60 second into 60, that is for minute, and for second we have to multiply with another 60. So this becomes 60 into 60 second. So this 0 cancels out, and we are left with 10 by 6 into 6 meter per second. That also means 5 by 3, or 5 by 18 meter per second. So if we write it down somewhere near here, so 1 kilometer per hour is equal to 5 by 18 meter per second. The velocity of the river flow is also given. It is 4 km per hour. So the river is like this. It is 200 meter wide, The stream is flowing in this direction like this, the water is flowing in the river like this, and our swimmer is swimming at an angle of 127 degree. So this is 127 degree, this point is A. There is another point which is vertically in the opposite direction B. Now the swimmer ends up, because there is a drag of water pulling him, so he ends up somewhere near here, and from that point he walks towards B. They want us to know what is the total time that he takes from reaching A to B. That is the time he would have taken if there was no drag in going from A to B, or he could have gone straight, and the time he has taken by walking from C to B. So we have to find out the distance from C to B. The speed with which he covers the distance from C to B is also given. We only have to find out what is the distance from C to B in meter. So this is Vs, and this angle is 90 degree angle because B is just opposite to A, so this is a straight line connecting A and B, so this angle is 90 degree. Therefore this angle is 127 degree minus 90 degree, which comes out to be 37 degree. So we want to find out the component of Vs along the direction of AB, and if you know the triangular analysis, if this is our vector and this is the angle, then along this direction the component will be r cos 37 degree, and along this direction the component comes out as r sin 37 degree. And this comes from analyzing a triangle. So this is for sine we have to divide these two, and for cos we have to divide these two. Using this analysis in terms of a coordinate system, we can simply write it like this, because if we draw a triangle over here, you can see that this part comes out as sine. So this vertical distance is given in sine function, and this is cos, therefore this part comes out as r cos 37 degree. So our velocity of the swimmer, let us take this as the y-axis and let us take this as the x-axis. So along the y direction the velocity of the swimmer is here 37 degrees, so cos 37 degrees simply. Now cos 37 is almost 0.8. So cos 37 is 0.8, Vs is given as 5 km per hour. If we multiply 5 by 18, we get it in meter per second. Multiply it by 0.8. This is the velocity of the swimmer along the y direction. So if he could swim straight across, if there was no river velocity present, then the time taken by him to reach from point A to point B would have been the distance between A and B divided by the velocity along that direction. So which is 200 meter divided by 5.5 into 18 into 0.8 second. Now to find out the distance from C to B, we have to find out the resultant velocity along the x-axis. Now the velocity of the swimmer along the x-axis is this is going to be the sine component of the velocity. So sine 37 degree, and the swimmer is swimming across this direction. So let me tell you how to find out the component of a vector. If the vector is in this direction, then it will have a x component along this and this direction. If the vector is like this, its x and y component will be along this and this direction. If our vector is like this, we want to find out the component along the x and the y direction, they will come out like this. So our swimmer is moving in this direction, as you can see. So its y component is along this direction and the x component is along this direction. Now if we consider this direction as the positive direction, therefore it will become the negative x-axis. So the swimmer's velocity is negative and the river speed along this direction which is positive. So this is the resultant velocity across the x-axis. So this comes out to be Vs is 5 km per hour multiplied by sine 37 degree plus Vr is 4 km per hour, and we are multiplying this by 5 by 18 to convert this into meter per second. Now sine 37 degrees 0.6, so this becomes 5 into 0.6 plus 4 into 5 by 18 meter per second. So the velocity component along the x-axis becomes, this is 30. So 4 minus 3, which is 1, or 5 by 18 meter per second. So the time taken in going from C to B, the distance between C to B divided by the speed with which it travels the distance, which is 3 km per hour, or 3 by 5 by 18, and this will come out in second. To find out the distance from C to B, we have to multiply this resultant velocity along the direction, which is this Vsx, with the same time in which it reaches from A to B, because while he was swimming from A to B, during that entire time this drag was acting on him. So we have to multiply this with TAB to find out the distance C to B. That means if we simplify TAB, it gives me 200 into 18 divided by 25 divided by 0.8. which is 180 second. So 5 by 18 into 180 meter. So CB comes out to be 5 by 18 into 180 divided by 3 into 5 by 18. 5 by 18, 18 cancels out. 180 by 3 is 60 second. So the total time taken is TAB plus TCB, which is 180 plus 60, or 240 second. If we divide this by 60, it will become 4 minutes. So the total time taken to go from A to B, that means to swim from A to C and then walk from C to B, is 4 minutes. If you have not yet understand, please revisit the video once again. This is a very important and interesting concept about finding out the component of a vector along a particular direction as per our need. Another application of that is a combined application of the concept of relative speed that we deduced in the problem involving two trucks, also the problem in which a ball was thrown upward from a balloon, and in the previous problem where we deduced how to find out the component of a vector. If we combine those concepts, then we can solve the problems of rain falling with a particular speed and an observer which is, or a person who is walking in the rain. So here they are saying that rain is falling vertically with a speed of 20 meter per second. So the velocity of the rain is along the negative y-axis. Let us consider this is our y and this is our x. So our rain has a velocity which is minus 20 meter per second. A person is running in the rain with a velocity of 5 meter per second. So a person is running in the rain and the velocity of the person, say man, the velocity of the man is 5 meter per second towards east, meaning in this direction. So 5 meter per second, 5 I cap meter per second. And the velocity of the wind, which is also in the east, which is 15 I cap meter per second. So the resultant velocity along the x direction becomes, they are moving in the same direction, so the resultant velocity becomes 15 minus 5 I cap meter per second or 10 I cap meter per second. So along this direction we have a vector which is 10 meter per second. So the resultant will be obviously along this direction, or the rain will seem to come from this direction. So what is the value of the resultant? We will also learn to find out the value of a resultant vector, which is nothing but root over square of each component plus 2 multiplied by the vector dot product, which comes out as the dot product. We know that A dot B is equal to the modulus of A modulus of B, or the value of A value of B, multiplied by cos of the angle between them. Here the angle between these two vectors is 90 degree and cos 90 degree is 0. So this term will cancel out. So we are left with 10 square plus 20 square, or 100 plus 400 root over 500, which is 10 root 5. This is the value of the resultant velocity, and we also want to know the direction of the velocity in terms of tan. So if we draw this triangle over here, let us take this angle as theta. Which is same as this angle, the angle with the y direction, which is theta. Or so in terms of tan, as in all the options they have given in form of tan, that is why we are writing in terms of tan. So you can see that tan theta will become, this is sine, this is cos, and this is tan. So tan theta becomes 2 divided, tan theta becomes this, which is 10 meter per second divided by this vertical, which is 20 meter per second, or theta becomes tan inverse 10 by 20, or tan inverse half. So this is the value or the modulus of the resultant velocity, and the direction of the resultant velocity is given. It makes an angle theta with the vertical. In all the options it has given along with the vertical. That is why if this is making an angle theta with the vertical, that means this is also the angle theta, and this is what my triangle gives out. Hope this example is very clear to you, because in our upcoming sessions we are going to solve a lot of problem involving relative velocities, resultant velocities, the component of a velocity along a particular direction, and other problems involving the 3 new equations that we learned in our today's session. One was the instantaneous velocity v, which is equal to the distance traveled divided by the time taken to traverse that distance. Another equation was v equal to u plus minus acceleration into time. Another was the distance traveled. If the initial speed was u, then this becomes half a t square. So we have to remember these equations. Also we learned about the time of flight. Now there are Apart from this type of problems, descriptive problems, there are another type of problems that will be given from this chapter, and those are the problems where you will be given a random graph like this, and you will be asked under what condition a particle will show exhibit this type of relation between velocity and time, or between distance and time, or between acceleration and time. They'll be giving you graphs like this. Either they'll be asking you to find out the equation of motion, or they'll be asking you the relation between b and t, for which the graph will show a form like this. So we will also solve in our upcoming session for this type of graphs. I will take a separate session on them. See you in my next class. Till then, take care. Bye bye.